All right, so this is a demo of a JIT PDB JIT, a PDB generator for JITs library that I've been working on. It was mostly intended for the compiler that I've been working on too, but some people were interested, so I thought it might be helpful to package it up as a standalone thing as well. Sort of only semi-standalone. But anyway, here's a quick example of it. So the setup is there's two fake Python files here. One is well, they're real Python files, but they're not really compiled. So there's an entry function that calls the main entry that calls another function, and then that function just returns a number. So it's super simple. There's no actual compiler happening here. There's just this blob of actual machine code, and these correspond to the two functions that are that match these source files. So there's no compiler here. There's just a blast of code. So we'll just step in and see how it goes. Create a context, give it the output file name, and allocate some memory to put your code into. Get playing and a little messing around to get file names, nothing, just something for the demo. And then basically create all the symbols, so all the functions and the ranges, the blocks of memory. So this is from the relative to the image base, how big the functions are, and then go through and each and add all the line information, so the address of where the line starts and the line number in the source file that it corresponds to. So obviously those would come from some sort of compiler internal data structure, not hard-coded in a file. And then we run down to here. So the this is where most of the work happens. So what's actually being done in the library is this generates first thing it does is generate a PDB with containing all the information that you set up here. And then it also actually generates a DLL, and the DLL doesn't have anything in it. It's not actually used to load the code. The code's already been jitted into memory, and it's there to be ready to execute it. But the DLL points to the PDB, and that is what convinces Visual Studio to actually load the PDB, because you can't directly tell it to load a PDB. So the DLL is just a reference to the PDB, and then when we do a load library on the DLL that's empty, it causes it to load the symbols. So you'll see when I step over here in the modules window, you get this, I called it blah blah synthetic.dll or whatever, some random goofy thing, but and you see symbol load information, it'll actually load the symbols, and that's all just kind of normally what would happen with the DLL. Which is totally unremarkable, which is kind of the idea. So you can see when we step in here, you pop over to this fake file that has sort of Python-y, and you can do things like view disassembly, mixed view, so you can see the code and the lines are the interspersed, and step out and step, say, into this next one. So this is the function that calls another function, so we can step in here, and then we see step in again, and you see the call stack of func and entry and main and sort of normal things. So you can step, and you can also do say set next statement, so jump back to see what's going on. So it's all just kind of normal. The main thing that's missing from the library is that it's only doing function symbols and line information. It doesn't do any type information yet, just because that was, well, really complicated, because PDBs are one crazy format, and also because I didn't need it right now. I mostly wrote this to help with debugging code generation in the compiler, which I think probably was not necessarily a great choice, because the idea was that when you see things like this, you're like, where did all this code come from? It would be nice to know what line it was even contributing to, which I probably had easier solutions to that problem. But I thought it would be neat to see this and see what was actually, what was causing that code to be generated. But I think if I spent longer writing the PDB library, then I could have just debugged the code. But anyway, maybe it's useful for somebody, or somebody will find it interesting, or reference. There's not that many writers of PDBs that are public. Basically, LLVM is the only one that I know of. There's lots of libraries to read them now, but not very many to write them. So it's actually a little trickier to write, I found. So anyway, maybe it's useful. That's all.